Okay, in this session, we are using Wolfram demonstration project. You can go to Wolfram Alpha website to do the same thing. So the goal of this demo is to understand the relationship between standard normal distribution and any normal distribution, and using standard normal distribution, how we can get the probability or the area under the curve for any normal distribution. So here you see two curves. On the left hand side, it's a standard normal distribution. Up at the top you see normal 0, 1. So that means that the mean is 0 and standard deviation 1. On the right hand side, we've got a normal distribution 15, 1. That means the mean is 15 and standard deviation 1. So normal distribution is described by two parameters. Up at the top you can see mu, the mean, and sigma, the standard deviation. So if I can, for example, the right hand side curve, if I move it, so what does it mean by different mean? So this is a mean of 3, this is mean of 6, mean of 10, and mean of 15. So the mean is just tells you the location where the center of the distribution is. Then the standard deviation is a variation. So I have now standard deviation 1, but if I increase the standard deviation of 1.6, standard deviation 2.1, and so on. So if we increase the standard deviation, then you can see it becomes wider and shorter. Okay, so let me go back to the standard deviation of 1. And then another interesting thing is if you look at the z value and then here the x value, so that is the data values. X is the data value, z is the corresponding standard normal data value. And you can see that there is a relationship between the z equals -1 here, and then correspondingly you see here x equals 14, and the relationship between the two is given on the bottom here, z equals x minus mu over sigma. So that's the relationship. For example, x equals 14 and the mean mu is 15, sigma is 1. So 14 minus 15 divided by 1, that is -1 over 1 is -1. So that's how we get z equals -1. So the way these two curves are structured is that this light blue area on the left hand side of the curve is exactly equal to the light blue area on the right hand side in this curve. So interesting questions in these kind of problems are z equals -1. What is the area under the curve to the left of z equals -1? And that's given here up at the top in the on the top. It says 15.8%, on the right hand side 84.1%. So that means that 15.8% of the data values of the standard normal distribution are below z equals -1, and 84% of the data values are above z equals -1. Another way to say that is 15.8% probability that z equals less than or equal to -1, and 84% the probability that z is greater than -1. Same way we can say here, so the same area, so this is the probability that x is less than or equal to 14 is 15.8%. So the two areas are exactly the same. Okay, so now let's change the standard deviation of the right hand side of the curve. So if we change that to 2, for example, the two light blue areas, visually, we are not able to see that they are equal, but mathematically they are equal. And if you do integration, you will be able to see that these two areas are exactly equal, or if you use a graph paper, you'll be able to see that. So what this means is that the area under the curve to the left of x equals 13 is exactly the same as the area under the curve on the standard normal to the left of z equals -1. Again, using the transformation, x equals 13, so z equals x 13 minus the mu 15 divided by 2, so that's -1, so that's what that is. So now the area under the curve to the left of x equals 13 is 15.8%. So how do we use it in solving problems? So let's pretend that this curve here on the right hand side, it is real data. It is the mathematics exam scores. Let's say that scores from a mathematics exam. and the mean score is 15, standard deviation is 2. So one of the interesting questions is you want to know what percent of the students got a score of 13 or lower. So you can answer the question, 15.8% of the students got a score of 13 or lower. Okay, and so this relationship between z and x, it is true for any value, not necessarily z equals minus 1. So let's say, we just change the z value. So now we have changed the z value to 1.42. So now you can see that there are this area to the left of z equals 1.42, that's 92%. So you can see that 92% of the scores are below 17.84. Or you can say that 92% of the students got a score less than 17.84. Or if somebody asks the question, if you randomly pick a student, what is the likelihood that that student is going to have a score of less than 17.84? You will say that's a 92% probability or likelihood that the student score is less than 17.84. So that's how you use the normal distribution to answer these kind of questions. And the standard normal distribution on the left-hand side is the z value and the corresponding the area values. Those are the two values that are provided in the statistic textbooks. And then for solving any other problem, normal distribution problem, you have a different mean and different standard deviation. So all you have to do is, using this relationship z equals x minus mu over sigma, you transform that x to z, so you can always use the standard normal distribution in the statistics book. Using the z-score, you can get the corresponding area, or if somebody gives you the area, you can get the corresponding z-score, and hence you can get the corresponding x value to solve any problem. Okay, thank you very much.